Okay, I don't know if this is going to work, but we're going to give it a try. So here we are. We're going to talk about binary, but if we want to talk about binary, first I want to talk about decimal. All right, this is how we already do it. We can count these dots, and if you go ahead and pause the video and count the dots, you'll find that there are 23 dots. Much better. There are 23 dots. How do we know there are 23 dots? Well, we have encoded these numbers. It's not a 2 and a 3. It's definitely not 2 dots and then 3 dots. It is 23 dots. And what we've done is we've said, hey, that number there means ones, that many there is groups of 10, and that is groups of 100. And we don't have any groups of 100, so we just leave that out, right? But we still say, that's the ones, that's the tens, that's the hundreds. This is no surprise, you learned this in elementary school. So what we're actually saying is that there are two groups of 10. So if I make a group of 10 now, let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that's 10. 8, 9, 10, good. And then another group of 10, which I think 1, 2, 3, 4, 5, 6, 7, 10. There's another group of 10. So there's two groups of 10, and then 3 left over. Right? No groups of 100. Right? I tried to, if you tried to make a group of 100, you wouldn't. So there's nothing there. When we're talking about binary, so this is what we call a decimal number. Decimal means base 10. All right, there are 10 digits in decimal. There's, what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's only 9. Of course, we have 0. 0 is very important. So, next question, why, or how do we make this into binary? Well, first we need to break down what is going on up in this decimal placement system. What we're saying is, so this 10 here is 10 to the first power, and this is 10 to the second power. And if you go 10 to the third power, you get thousands, right? Because 10 to the third is 1,000. And then if you track back, 3, 2, 1, this is actually 10 to the 0. So it's still base 10, but it's 10 to the 0. Anything to the 0 is 1. There's a really good reason for that, but the short version is that math breaks if that's not true. So now how can we do that with a different base? And the short answer is yes, and the long answer is yes. We call it binary. And it is base 2. Now, in binary, we only have 2 possible values for each digit, each binary digit. I'll tell you about those in a second. 0 and 1. It means that it's going to be longer, but it also means that it's going to be a lot less complex. So this is going to be 2 to the first, 2 squared, 2 to the third, and so on. So this is 2 to the 0, 2 to the 1, 2 to the 2. Sorry, I missed that. So that's going to be the 1's place, the 2's place, the 4's place, the 8's place, the 16's place, the 32's place, and so on and so forth. If we took all these dots here, which we called 23 in decimal, and we tried to figure out what they were in binary, we would do the same thing. We'd say, are there any 32s? Well, there are no 32s. And math rules say that if you have leading zeros, you can just leave them off. Like, for example, we don't really put a 0 in front of the 23. We're not going to do it quite that way here, but for a reason, and we'll get to that in a bit. Are there any groups of 16? Well, I think so, yeah. There's 4, let's see, 4, 1, 2, 3, 4, there's 4, there's 4, and there's 4. There's a group of 16, I think. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16? Wait, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Too many. Yep, overshot that. So there we go. So that's one group of 16. I'm left with 1, 2, 3, 4, 5, 6, 7. How many 8s are there in 7? There are no 8s in 7, so I'll put a 0 there. Are there any groups of 4? Why, yes, there's a lovely group of 4 right here. So that's one group of 4. Leaves us with 3. How many groups of 2 are there? There's one group of 2, and there's one left for a group of 1. And so our binary number is 10111. That is binary, basically. If I were to do this with 8 binary digits, it would look like this. And the reason I'm doing this is because I want to, I want to do that bigger. Ooh, no rehearsal. This is how you know it's a raw performance. Sure. 1, 2, 4, 5, 6, 7, 8. Perfect. So we got 1s, we got 2s, we got 4s, we got 8. You can really build this simply by starting at 1 and doubling each time. And then 128. So we're going to stop at 8. And the reason we're stopping at 8 is because of nomenclature. So this here number up here would be 0, 0, no 32s, 116, no 8s, a 4, a 2, and a 1. All right. One single binary number or binary digit, this is called a bit. All right. So from now on, you're going to hear me call them bits. 8 of them together make something called a byte with a Y. Now you've heard of these bytes, right? Like, how much RAM do you have? Gigabytes. What's your you've heard of bits before too. What's your upload speed? 30 megabits, right? There is there's another grouping. This byte is also called an octet because it's 8 oct. There's also a word because computer scientists are always amused by themselves, or at least try to amuse themselves. And so half a byte is a nibble, sometimes spelled with a Y because of byte. That's a nibble. All right, so cool, great, wonderful. We need video in order for me to teach you how to count. So you can use binary to count on your hands, and you can count up to 31 on one hand, assuming you still have all 5 fingers. Or at least started with 5 fingers and still have them. You can count all the way up to 63 if you've got 6 fingers on your hands. And I'll show you how to, remind me in class to show you how to do that, because it really does need video. All right, let's talk about converting from binary and to binary. I guess each page is its own video, so I'm going to have to save this. So there are 2 ways to convert. We can convert from decimal to binary, or we can convert from binary to decimal. And binary to decimal is probably the easiest. So let's start with that. Let's take a number, 101010101. There we go. No idea what that is off the top of my head, but that's okay. One of the things that will be useful is to mark the places for each part of the binary number. Now, one of the things I like to do is I like to, up in the corner of my paper, just write the places to remind me what all is there. And all I need to do is start at 1 and double each time. So 1, 2, 4, 8, 16, 32, 64, and 128, and that's 8 bits. So here's how we go through it. We'll take a look at the first bit, and are there any 128s? Yes, there's 120. Well, there's one 128, so I'm going to add that to my number. Are there any 64s? Nope, that's 0. Are there any 32s? Why, yes, there is a 32, and I'm going to add that to my number. I think that's right. Carry the 1. Yep. All right, that was 32s. Are there any 16s? Well, look at that. Yes, there is. So I will add a 16 to this, and I will get 176. Are there any 8s? Nope. Are there any 4s? Yes. So I'm going to add a 4 to this, and I'll get 180. Are there any 2s? Nope. Are there any 1s? Yep. So I will add 1 to that, and I will get 181. And that's my decimal number. When we're converting from decimal to binary, on the other hand, there's 2 ways to do it. There is a slow but easy way and a fast but hard way. I'll show you the slow, easy way first. We start with 101, or 181. I'm going to do a different color just to... All right, so we start with our 181. I'm going to do 181. There's 181. Cool. All right, so once again, we've got our 128, 64, 32, 16, 8, 4, 2, and 1. And we're going to build this binary number from left to right. So are there any 128s in this binary number, or in this decimal number? Yes, I can. So I will put a 1, and then I will subtract 128. If there were none, I'd put a 0 there. So let's see, that's going to be 12, make that 11, or, dang it, 11 minus 8 is 2, it's actually going to be 7, so it's going to be 52. I have 52 left. All right, are there any 64s in 52? Nope, I'll put a 0 there. Are there any 32s in 52? Why, yes. So I will take that out, and I will end up with 20. I am a lot better at, oh, that's about 32 right there. I'm a lot better at adding than I am subtracting. Are there any 16s in that thing? Yep, there are a... Hang on. I've just discovered an error. Did I mention I'm really bad at this? 11 minus 8 isn't 2, it's 3. There we go. 21. Are there any 16s in 10? Recovered. Are there any 16s in 21? Yes, there's definitely a 16 in 21. And that's going to give us, what, 5 left? So there's my 16 to put there. Are there any 8s in 5? Nope. Are there any 4s in 5? Yep, there's a 4. So I'm going to put my 4 there and subtract 4 from my 5 and get 1. Are there any 2s in 1? Nope. Are there any 1s in 1? Yes. So there's my binary number. And you'll notice it matches my original. All right, let's do my favorite one. That's, we use that we're dividing. And we're not just dividing, but we're also keeping a remainder. If you remember from elementary school, when you used to divide, I don't know if they teach it this way anymore, but you would divide, and if it didn't divide evenly, you'd have a remainder. So, for example, 7 divided by 3 is 2, remainder 1. So we're going to be interested in the remainders, and we're going to build our binary number, this time from right to left. So we'll start with 181. And what we're going to do in each step is divide by 2. So 181 divided by 2 is 90, remainder 1. So I put my 1 down here. 90 divided by 2 is 45, remainder 0. So I'll put a 0 here. 45 divided by 2 is 22, remainder 1. Put that 1 right here. 22 divided by 2 is 11, remainder 0. Put that 0 right there. 11 divided by 2 is 5, remainder 1. So I'll put that remainder right there. 5 divided by 2 is 2, remainder 1. So I'll take that remainder and put it right there. 2 divided by 2 is 1, remainder 1. 1 remainder 0. What am I saying? 2 divided by 2 is definitely remainder 0, so I'll take that remainder and I'll put it right there. And then 1 divided by 2 is 0, remainder 1. So I'll put that right there. And now I've gotten to 0, so I'm done converting the number. And you'll notice that it matches with all of the other ones. Alright, that's it. If you have any questions, hit me up on Discord, and have a great weekend. Peace and unrest.